Today we're going to solve square root radical functions algebraically, and it's May 28th. Your note packet should have 3 pages. All right, let's go through the process that we're going to use to solve our square root radicals. Ultimately, the goal is to isolate the square root radical. So if you see any constants hanging around, we want to add or subtract those so that we can start to get that square root radical isolated. If there's a coefficient sitting in front of your square root radical, we want to get rid of that. So if we're multiplying by a whole number, we want to divide both sides. If it's fractional, we want to multiply by the multiplicative inverse. But ultimately, we want that coefficient to go away. Once you've got the square root radical isolated, we're going to square both sides of the equation so that we can get rid of that square root radical. We're going to solve the remaining equation. And then we have to do some checking. Sometimes we solve everything correctly, the solutions look good, but when you sub them back in to check, we're going to realize that some or all don't work at all. And really that's what extraneous is. They're just solutions that won't work. We're going to start simple in example 1. We're looking for the value of a. So in order to get rid of that square root radical, we need to square both sides. So the square root and squaring of a value just leaves the value itself. So I have a equals 100. If I check this, I'm going to sub it back into the original function. So we're going to plug in 100. And normally we would have a positive and negative root, so positive and negative 10. But we learned yesterday that when we graph square root radical equations, we only acknowledge the positive root, and we're going to do the same when we solve them algebraically. In example 2, you'll notice we have square root radicals on both sides. To get those to go away, we need to square both sides. And by doing that, you've eliminated those inverse pieces, and we're going to be left with 9x equals 8x plus 1. You can go ahead and solve. We're going to combine our like terms, and we see that x equals 1. We're going to perform our check. I'm going to sub 1 into both sides. And you can see as we go through the check that 3 equals 3. So 1 is an appropriate solution. Now, this one's a little trickier, and it's not that it's difficult, it's just the little things. So, in order to get the square root radical to go away, we're going to square both sides. On the right-hand side, the quantity of x plus 1 must be put into parentheses before you raise it. And to move forward in the process, we want to write that factor of x plus 1 twice so that we can distribute appropriately and we won't lose any of our terms. So I'm going to go ahead and distribute. And I can see that it's a quadratic equation. So I'm going to move all my terms to the right-hand side to keep my quadratic term positive, and I'm going to set it equal to 0. And at this point, you can choose any factoring method that you like. When I look at this quadratic, I see the difference of perfect squares. So I know that the quantities are x plus 2 and x minus 2. And each factor gets set equal to 0. So my roots are at negative 2 and positive 2. So these would be my solutions. But again, we need to check that both of them are acceptable solutions. I'm going to start with our root of negative 2. And as I go through, I have the square root of 1. And remember, we're only taking the positive root. So this root doesn't work. We'll also check positive 2. And we can see that that root actually does work. So we're going to reject the root of negative 2 as an extraneous root. And we're going to keep the root of 2. In number 4, we see a little bit more in the equation itself, and this goes back to the procedures. So the first step was to get rid of any constants hanging around. So I'm going to add 2 to both sides to start the isolation process. And I also have a coefficient in front of the square root radical. Since we're multiplying by 3, we will divide both sides by 3 to make that go away. And this is the result. In order to get the square root radical to go away, we're going to square both sides, and that will leave me 4a squared equal to 4 squared. And this is just a simple one-step equation. The value of a is 4. We're going to go ahead and perform our check. So into the original equation, we're going to slowly work through. We don't want to fake our check. So 16 is a perfect square. And when I finish up the math, I can see that this solution does check. So 4 is an appropriate solution. Number 5, this one doesn't look too bad. We're going to go ahead and start the process by squaring both sides. Remember, when you raise a negative number, we need to put the entire term in parentheses so that we don't lose a sign. All right, we're going to subtract 3 from both sides and get a solution of 22. Now, when I go ahead and check, we're going to sub 22 in. But remember, we're only going to acknowledge the positive root on the square root of 25, and this solution does not work. So there is really no solution to this. So 22 is an extraneous solution. This one has a square root radical that's in the form of a fraction. That's okay. We're not going to do anything different. We're going to start by adding 9 to both sides. And now we're going to go ahead and square both sides to eliminate the square root. So I'm going to be left with 4/5 x, and that equals 144. I'm going to start the process by multiplying both sides by 5 to get rid of dividing by 5. And now I can go ahead and divide both sides by 4, giving me a solution of 180. Let's go ahead and run our check. So we'll sub in 180. 144 is a perfect square, and 12 minus 9 is 3. So 180 does work, and it's an appropriate solution. And number 7. The square root radical is isolated, so we can go ahead and square both sides. When I do that, the radical disappears on the left, but now my value of x is squared. This is now a quadratic equation. Since the quadratic term is positive, I'm going to subtract 5x and add 6 to both sides and set my quadratic equal to 0. Again, you can use any factoring technique that you like. I'm going to use product sum. So I'm looking for numbers that multiply to 6, but also add up to -5. So both of my factors are negative. And that gives me a root at 2 and a root at 3. Now we need to check that both are acceptable solutions. I'm going to start with the 2. And as I go through, 2 does work as a solution. Now we'll check 3. And we see that 3 works as well. So both 2 and 3 are appropriate solutions. Your homework tonight is number 122. Your homework will say solving square root equations at the top, and I believe there's anywhere from 12 to 15 problems. If you have any questions while you're going through your homework, please make sure you get in touch with me, and I'm happy to help. Have a great day.